Um, I want to go over a another LeetCode problem where we have to find the max depth of an n array tree. So in my last video, I sh showed y'all how to make an n array tree, and this is kind of similar to the max depth of a regular tree. Um, very similar to it. But in this case, we're checking um the vector of nodes a within the n-array tree instead of just two nodes like we did before. So real quick for this class solution, like LeetCode does it, how LeetCode wants it. Solution. Here we're gonna have int max depth. Oh shoot, I can't spell depth. And then we're gonna pass in a node pointer root. Um, okay. So in here, we're going to define our base case as if root is equal to null pointer, we're going to return 0. Um, and then after each recursive call, we're going to have it's essentially like a counter to count the current depth of the node. So int max depth of node or of tree, let's call it tree, is equal to 0. So after each recursive call, it's going to set this max depth to 0. Um, okay, and then after that, we're going to do a for each loop for node child within the current root's children vector. We're going to search to the current node's child vector. So in this case, for 5, we would search to 3, 4, and 6 because this is within the vector. Within 3, we would search in between just 8, and then for 8, we would just search in the vector. We would just search 10 because that's the last node within 8. And then 10, we wouldn't search anything because there's nothing connected to 10. So for node child within the current root's children vector, we're going to say max uh, depth of tree is equal to std max. So whatever the max is between max depth of tree, comma, um, and then recursively call the uh max depth method on the current child. Um, yeah. And then here we would return max depth of tree plus 1. Um, okay, so what's happening here is we're going to be passing in. So for this example, um, we're going to be passing in 5 as the root node because that's how we did it here. I'm using the same tree from my last video. I haven't changed anything. Everything's still the same. Um, okay, so yeah, max, we'd be passing in the root 5 first. So we would check if 5 is a null pointer right here with this, and if it is, we return 0. In this case, it is not. So we initialize max depth of tree to 0. So for this guy, the current max depth of its current max depth is 0. So then we would initialize the for each loop, checking each node in the vector within in the child vector within 5. Um, and we would say 0. So in this case, max step 4, 5. So we're going to say 4, 5. Max depth is 0 is equal to, because we initialized in the first recursive call max depth of tree to be 0. And that's what we're saying here. 0 is equal to the max of and then max depth of tree, which is still 0, And then I'm gonna just say MD. This is the recursive call. This is this function right here. MD of whatever the first ew, what an ugly D. MD of whatever the first node is within this vector. And in this case, we would say 3. So 3. Now, since we have a recursive call here, before even doing anything else, we would then check, um, because it's a recursive call, we would then check the children node, the nodes within the child vector of 3. So we pass 3 back into here as the root node. So we would say for 3, we would check if 3 is a null. In this case, it is not. We initialize 3's current max depth to 0. So 0 is equal to the max, whatever the max is between 0, again, because 3's current max depth is 0, comma, recursively call max depth function on whatever the child node is within 3. And in this case, it's just 8. 8. And now we would pass in 8 for here. Check if 8 is a null. If it is, we return 0. In this case, it's not. So for 8, 0 is equal to max of 0 and whatever the child node of 8 is, and in this case 10. 10. Uh-oh, I forgot MD. Max depth of 10. So recursively call the function on 10. Check if 10 is we would pass in the node, this would be our new node now, new root node 10. Pass it into here. Is node 10 equal to null? No, it's not. So for node 10, for 10, again, max depth is equal to 0. Max between 0 and max depth of its children node. In this case, it would be null. So we just pass in null right here. Recursively check max depth of null. In this case, our current root is it would be null because there's nothing here. So we would just return 0. We don't have to do anything else after this or after this right here. So now what we do is the current depth of 10, we would change this to 0. And then we would check the max between these two. And then whatever the max is, we would return for this current node's height, we return that max plus 1. In this case, both of these are 0, so we would just return 0 plus 1. So once we do this recursive call is over. 10's current depth is equal to whatever the max is between 0 and 0 plus 1. Doesn't really matter because they're both 0, 1. So 10's depth right now is 1. And this is kind of working backwards like the previous uh, tree node. So it's going to be going like this, checking the heights. So then we close this. Now we know what the depth is of here, of this guy. So we can pass in 1 now because we know what the depth is of 10, 1. We would return for 8's current height. We would return whatever the max is between 0 and 1 plus 1, which is 2. This function call is now closed. So we already got the height. We're doing this one right here. Return whatever the max is plus 1. Now for this one, for 3, we know what the height is of 8 here, which is 2. Pass in 2. Calculate whatever the max is between these two numbers. In this case, it's 2 plus 1. This guy is closed. We already know what it is. 3's current height is returned to be 2 plus 1, 3. Now, before we return to this calculate this guy, we would since remember how I said we were checking all of the root nodes, um now we would check the root nodes of 4 and 5. So our current max node for when we're checking 4 would be 4 5. We would enter a new recursive call for 5. So now for 5, essentially we're doing these steps again. For 5, we would return um our current max depth for 5 is 3, because that was the height of our current last one. 3 is equal to the max between 3 and max depth, recursively call max depth of 4 now. Um, Now for 4, since we recursively called 4, max depth of 4 is now set to 0, like we had here before, and like we had here on these other ones. 4 is equal to the max depth of it. This is inside of its own thing. So we would return max of 0, and in this case null, because there's no nodes connected to the 4. And since it's null, what do? We return 0. So instead of null, we're returning 0. Return whatever the max is between these two plus 1. So 4's depth is 1. We can close this one out. And here we know that we're now comparing, we're now comparing 3, the max between 3 and 1. In this case, we would keep 3. And we would do this process one more time for 6. And I won't show 6 because it's exactly the same steps as for 4, because there is no other nodes. So we would be comparing. Then we can finally do this last step right here. Imagine we did the same thing, and so this is the height for 6 now. We would now compare this a bit wider. Compare so the height for 5, we would compare whatever the max is between 1 and 3, add that plus 1. So 5's current height is equal to 3 plus 1, 4. So that is how we get the max depth. And if you don't believe me, let's show it. Solution in max depth is equal to solution dot this is not public solution dot, oh man, and then max depth, and then we would say tree dot get root, and end that right there, and then stdc out max depth of n array tree is max depth and L. So if we run it, what do we get? 4. And what did I get? 4. Yes. So that is that, and you can see it right here. 1, 2, 3, 4. The depth for this one is just 1, 2. Depth for this is just 1, 2. So, or the depth, yeah. If we were to compare these two, this depth from 5 and 4 is just 2. From 5 and 6 is just 2. And this is 4 right here. So yeah, that was the max depth of an array tree. Here's the code again. Uh-oh. Yeah, hopefully I explained it quite well. Please let me know if I didn't, or if you have any questions, comments, or concerns. Thank you for watching.